Today, we're taking you behind the scenes to see how laptops are made. Subscribe ahead of time. Welcome to the future of manufacturing. It all starts right here, with the careful selection of raw minerals. Here at the Crucible, our robotic arms precisely manage the intense heat, stirring the molten silicon to create the perfect wafers you rely on. Next up, the ingot slicing. We use shear force and precision, along with this cooling liquid, to transform the silicon into mirror-like wafers.
Here we see the precision grinding process, essential for achieving the perfect uniform thickness required for modern microchips.
This automated polishing machine works tirelessly, transforming the rough ground silicon wafers into perfectly smooth, mirror-like surfaces. As you can see, the wafers undergo a rigorous automated cleaning process right here, removing any microscopic contaminants before the next critical stage. The wafers are passed through this high-temperature furnace to form a thin oxide layer, a crucial insulating step. This is the photolithography area. The robotic arm applies the photoresist coat to the spinning wafer, defining the circuit pattern with pinpoint accuracy. This is where the magic happens. The automated lithography machine uses focused UV light to precisely transfer the intricate circuit design onto the wafer. Next up is the developing process. As the photoresist washes away, it reveals the intricate black and silver circuitry beneath. Plasma etching is used to precisely cut away layers of the wafer, transferring the photoresist pattern into the underlying silicon structure. Boards. The machine bombards the wafer with ions, changing their properties of specific regions to create the semiconductor components. A controlled heating process, or annealing, repairs the crystal lattice damage caused by ion implantation, ensuring the transistors function correctly. Automated equipment deposits and patterns metal layers onto the wafer, creating the electrical interconnects that link the hundreds of millions of transistors. This is planarization, a vital polishing process that smooths the metal layer, ensuring a perfectly flat surface for the next layer of circuits. This is the heart of the operation. As you can see, the automated probe station is conducting electrical tests on the wafer. This is where we push the boundaries of technology. Our automated systems ensure unparalleled precision, especially during critical
is die mapping in action. Using the grid map, the robot precisely selects the successful dies for future processing.
This is where we slice the wafers. The diamond saw, cooled by this continuous stream of water, precisely dices the wafer into individual microchips. Welcome to the future of manufacturing. These pick-and-place robots operate at incredible speeds, ensuring precision at every stage of the assembly line. The die is bonded to the substrate using a precise amount of adhesive dispensed by the automated machine, preparing the chip for wire bonding. An incredibly fine gold wire is bonded to the chip, creating the crucial electrical connections between the silicon die and the chip package's leads. Next up, we apply a protective polymer right beneath the chip. This underfill absorbs stress and shields the wire bonds from any damage during manufacturing. The chips are sealed in a protective black epoxy compound to shield them from environmental damage and allow for easier handling. As you can see, the high-precision trimming tool separates the individual packaged chips from the substrate frame, preparing them for final testing and integration. As you can see, the process is fully automated. This laser marking ensures every package has a unique identifier before it moves to final testing. This automated process ensures every CPU meets our rigorous standards. The stress test data is immediately visible right here. This is where the magic happens. The GPU wafer prep stage is critical for performance. This is where the magic happens, folks. The lithography machine uses intense blue light to etch the circuit designs onto the wafer with pinpoint accuracy. Intense plasma etching carves the delicate, multi-layered circuits of the GPU onto the silicon, creating the foundational structure right before your eyes. This advanced deposition machine is layering the necessary metal onto the GPU wafer, a crucial step for creating the electrical paths of the graphics card. The diamond saw separates the functional GPU dies from the wafer, a precise process cooled by a continuous spray of water. The robot precisely places the GPU die onto its substrate with a gentle but firm motion, bonding it perfectly for the next steps. As you can see, the hydraulic press is now applying the thick black epoxy resin, ensuring maximum durability for these GPUs.
Thermal stability is solid, but look at the clock fluctuation here.
It's within tolerance.
The final memory check just passed.
This is where the magic happens. The assembly line moves at incredible speed, focusing on the precision placement of these RAM wafers. This is where the magic happens. We use focused blue light to precisely pattern the tiny features on the RAM wafer, defining the memory cell structures.
The next step is plasma etching, where you can see the purple plasma precisely sculpting the memory circuits onto the RAM wafer.
Right here, we're witnessing the critical RAM deposition. This high heat process creates the electrical pathways for the memory chips. Come back to the facility. Now we're looking at the critical dicing stage, where the diamond saw separates the RAM dies from the wafer with incredible precision.
The robot precisely places and bonds the RAM dies onto the module substrate, creating the foundational memory chips for the laptop.
The automated press is encapsulating these RAM chips, sealing them with a protective resin before final installation. It's a beautiful process to watch. Right here is where the magic happens. Our state-of-the-art robotic arms test every single RAM module in a simulated server environment. Welcome to the future of memory production. Right here is where we prepare the NAND flash dies for final circuit patterning.
And right here, you can see the UV light precisely etching these incredibly dense, multi-layered patterns onto the wafer.
Plasma etching precisely defines the 3D structures of the NAND flash memory, creating the complex vertical storage cells.
In the deposition area, these machines work in tandem, laying down the multiple layers that form the stack structure of 3D NAND flash memory. This is where the magic happens. We're looking at the precise stacking of NAND flash layers, creating high-density storage modules. And this is where the magic happens. The automated press encapsulates the NAND modules, completing the SSD package. As you can see, the robotic arm subjects the NAND module to rigorous functional tests right here, ensuring complete data integrity before it moves on. Welcome to the facility. As you can see, the foundation of our PCBs begins right here with these fiberglass epoxy sheets. And this is where the magic happens. We're looking at the precise application of the copper cladding onto the fiberglass base layer.
This is where the magic happens. A photolithography process transfers the circuit pattern onto the board using
The unprotected copper is removed by a chemical bath, leaving only the desired circuit traces protected by the photoresist.
a high-speed CNC machine drills thousands of precise holes in the PCB, creating the vias for through-hole components and interlayer connections.
Welcome to the plating stage. We immerse the PCBs in this orange-brown solution, allowing the copper to bond and enhance the conductivity. A UV curing process hardens the green solder mask onto the PCB, protecting the copper traces and exposing only the areas designated for soldering.
Here we have the crucial silkscreen application, providing essential reference points for the next stage of assembly.
Now we move on to PCB routing. The CNC machine meticulously separates the large panel into individual, final-sized motherboards.
Check the alignment on this trace. That's definitely off spec.
The first step is SMT paste printing. As you can see up close, the machine applies a precise amount of silver solder paste through this stencil.
Right here we have the SMT pick and place machines. As you can see, they rapidly install the tiny electronic components onto the PCBs with pinpoint accuracy.
As the PCBs move through the reflow oven, the intense heat melts the solder paste, ensuring perfect electrical connections every time. Now the automated machines get to work, inserting the larger through-hole components, like these capacitors, right into the PCB.
Here we see the underside of the PCB as it crosses the wave of molten solder, securing every through-hole component in place.
This brings us to the crucial stage of board inspection, ensuring flawless quality control on every single unit.
As you can see right here, the robotic arm ensures the perfect alignment for the microcontroller mount.
Right here is where the magic happened. The automated soldering iron secures the CPU socket, ensuring a perfect connection every time. And right here is the critical connection point. Our automated systems precisely solder the GPU, ensuring flawless performance before it moves down the line. And right here, the robotic arm is assembling the voltage regulator module, the VRM, which is absolutely critical for providing stable power to the processor. This is the heart of the operation. The precision soldering of the RAM slots is fully automated, ensuring flawless connections every time.
This is where the magic happens. The robotic arms ensure millimeter precision when mounting the M.2 slot connector onto the motherboard.
The external I/O ports are soldered to the motherboard, ensuring reliable connections for peripherals and networking. The robot precisely mounts the Wi-Fi chip onto the motherboard and solders it, preparing the device for wireless connectivity.
Here you can see the automated soldering iron installing the power delivery components, ensuring the circuitry is both stable and robust.
As you can see, the precision here is unmatched. These robotic arms handle the delicate audio circuitry, ensuring perfect sound every time.
Here we have the critical speaker wire solder. This requires incredible precision, connecting the wires directly to the PCB for flawless audio.
And right here, the automated system dispenses a perfect bead of adhesive onto the webcam PCB. It's this level of precision that sets us apart. This is where the magic happened. The robotic arm solders the touchpad controller chip onto the main board with absolute precision.
And right here, the machine carefully solders the keyboard matrix onto the PCB, connecting the key mechanisms to the controller chip.
We have an automated process installing and soldering the battery management system circuit board, or BMS, which controls the charging and discharge of the battery pack. And right here is the fan controller chip being soldered onto the motherboard, absolutely essential for thermal management. Welcome to the testing phase. This high-resolution camera meticulously verifies the placement and soldering quality of every PCB. We use this advanced X-ray scan to look beneath the CPU socket. As you can see, the grid of solder balls.
As you can see behind me, every single motherboard undergoes a rigorous burn-in test, exposed to high temperatures and heavy loads.
The next step is crucial. This powerful laser precisely cuts the metal chassis pieces from the large sheet with incredible accuracy.
Right here is where the magic happens. This hydraulic press stamps the metal chassis with incredible precision. And this is where the magic happens. The robotic arm bends the chassis with absolute precision.
Today we're looking at CNC milling. This machine precisely carves complex shapes and contours directly from a solid block of aluminum.
This is where the magic happens. We use high-speed grinders for the edge trimming process, ensuring a perfect finish every time.
And this is the critical screw post forming stage. Watch as the robotic arm precisely integrates the components into the chassis.
And right here, the laser cutter precisely creates the intricate ventilation grill pattern on the metal panel.
Here in the facility, you can see the CNC machine creating that tiny, precise camera hole in the metal chassis. As you can see, the milling machine is currently creating the precise port cutouts for the chassis. Absolutely flawless work.
And surface sanding, as you can see, is a critical step. Our team ensures every chassis meets the highest standards of uniformity.
Next up is the anodizing process. This chemical bath gives the aluminum chassis its signature blue finish, making it incredibly durable and resistant to corrosion.
Here we use robotic sprayers to apply the protective powder coating, preparing the chassis for its final finish. The CNC machine is precisely milling the intricate pivot mechanism for the laptop screen hinge from this block of aluminum. So, this is where the magic happens. The hinge fitting requires incredible precision, and our team here.
This is the keycap molding process. The molten plastic is injected into the molds and then cooled rapidly before moving along the conveyor.
This is where the magic happens. The specialized printing head applies the legends directly onto the keycaps with incredible accuracy.
Here on the assembly line, we combine the efficiency of robotics with the precision of our skilled team for the keyboard assembly.
Hi, our high-tech facility utilizes these incredible articulated robotic arms. Welcome to the future of manufacturing. Here, you can see the precise touchpad bonding process in action. This right here is the speaker housing. It's critical for the laptop's audio performance, and as you can see, the robots assemble it with incredible precision.
A heavy press uses precise pressure to form the individual battery cells, a crucial step in creating the compact lithium-ion polymer batteries.
As you can see, the automated rollers are precisely layering the lithium, anode, and cathode materials. And this is the critical step of cell sealing. The robotic press applies heat and pressure, protecting the internal components of the battery.
Here we use a high-precision laser to weld the nickel strips onto the battery cells. This ensures a perfect connection every time.
This is where we install the battery management system, or BMS. It's a critical step performed by our skilled technicians right here on the line. Right here is where we test the finished battery packs. We're looking at capacity, charge cycles, and overall performance data right on these screens.
Welcome to our state-of-the-art facility. This high-precision laser slices the display glass with incredible speed and accuracy.
This is the OLED IPS bonding stage. The robotic arm ensures a perfect seal, optimizing the display panel to the glass cover.
This is the backlight assembly stage, where our specialized robots ensure perfect alignment of every single LED.
Here is the backlight assembly stage. These articulated arms precisely seal the display, ensuring a perfect fit every single time.
Next up is the bezel fitting process, where these robotic tools secure the display assembly clips with pinpoint accuracy.
Intricacies. As you can see, the robotic camera performs a final check for color accuracy. Once approved,
Here in the clean room, precision is everything. This machine ensures the thermal paste is applied perfectly every single time for optimal cooling. The copper heat pipes are soldered directly to the heatsink base, forming the heat transfer backbone of the cooling system.
here at the testing station, we use a pressurized water mist to confirm the balance and performance of every cooling fan before final assembly. Welcome to facility. Next up, the cooling install. This automated tool ensures the perfect fit for the heatsink and fan assembly right onto the CPU socket.
Next up, the memory installation. Our team ensures every component is seated perfectly.
As you can see, the M.2 SSD is installed directly into the slot and then secured with a small screw for perfect integration.
Welcome to the future of manufacturing. Right here, we're installing the critical Wi-Fi component. The final step here is the motherboard mount, executed with pinpoint accuracy using our precision tools. This is where the real precision comes in, and the team meticulously routes and connects these flexible flat cables right here on the motherboard. Welcome to the future of manufacturing. As you can see, our assembly line combines precision robotics with the expertise of our skilled technicians. As you can see, the assembly line is moving smoothly. Here, the touchpad is precisely installed before moving to the next phase.
Next up, the speaker installation. Our technicians carefully integrate the audio components, ensuring crystal clear sound quality every time.
And just like that, the battery is connected, ready for the next phase of testing.
This is where the magic happens. A power tool secures the robust metal screen hinge directly to the chassis, guaranteeing long-lasting durability.
This is where the magic happens. The display assembly is carefully secured to the chassis, a critical step we call screen attach.
The machine closes the final chassis panel and secures it with screws, completing the physical assembly of the laptop. As you can see, the assembly line is fully automated. And now for the moment of truth, the very first boot sequence. Look at that, flawless.
Welcome to the heart of our production line. Here, precision is everything as we move to the final stage of quality control, the BIOS flash. From assembly to quality control, our process is fully automated. And this right here is the OS imaging.
And now the technician executes the final driver installation to ensure all components function correctly. Look at that, success.
Come back to the factory floor. We are now looking at the final stage, the stress test, ensuring our thermal management system can handle the heavy load.
To ensure the highest quality, we bring every unit into this anechoic chamber for acoustic testing. We measure the noise levels of the cooling fans.
Right here, the robotic arm performs the drop test, ensuring that every laptop meets our high standards for durability. This is the thermal chamber. Inside, we push these devices to their limits with extreme temperature and humidity changes. This is where the magic happens. Our final inspection guarantees top quality, ensuring every unit meets our high standards.
Utilizing advanced robotics and our dedicated team, we move to accessory packing, ensuring everything is perfectly placed for you.
And now for the documentation. We ensure everything is included before the box is sealed and ready for shipment.
Here in the boxing segment, we combine the precision of our skilled workers with the tireless efficiency of our automated sealing systems. The robotic arms handle the pallet loading with incredible precision, ensuring every box is perfectly aligned before the automated wrapping process begins.